Okay, we are about to start the thesis defense of Guilherme Cavalcanti. He was advised by Paulo Borba. The title of his work is Should We Replace Our Merge Tools? So Guilherme is going to have like 50 minutes, right? And then we are going to start egging Guilherme for his work. I mean, first we are going to call people from outside, Sven and Leo, and then I'm gonna ask, the other members of the committee, to discuss his work, right? So the plan is to talk for like 20 minutes, just to keep, to control the time a bit, right? Of course, we can interrupt. This is not strict. Right, but this is only the plan. So the committee members are Leopoldo, Breno, Miranda, Leopoldo, Teixeira, and Marcelo myself. Right, and from outside, Leonardo Motta from Universidade Federal Fluminense, and Sven from Salland University. So Guilherme, it's all yours.
So before we start, I'd like to thank you all again for accepting to be the examiners. I really hope you have enjoyed my work. And now let's find out if we should replace our merge tools. So this work is in the context of collaborative software development, that is software developed by teams of developers. In this context, tasks are assigned to different developers, and these developers work individually using copies of project files. As a result, when they need to integrate the code contribution from each task, they might have to deal with conflicting changes and dedicate substantial effort resolving merge conflicts. These conflicts usually happen when using unstructured merge tools, which are the state of practice. This kind of tool operates purely on plain text, and if developers change the text in the same text area, the tool notifies conflict. This kind of tool is fast, it works with every kind of textual content, including source code, but it might report too many unnecessary conflicts. In an attempt to overcome disadvantages associated with unstructured merge, advanced merge strategies have been proposed. Structured merge attempts to improve unstructured merge with respect to conflict detection and resolution by exploiting the full syntactic structure of the merged artifacts. So it's specific to a programming language and uses information about the language, for instance, the grammar of the language, to resolve the largest possible number of conflicts automatically. In turn, semi-structured merge works on simplified path trees representing the program structure. Such trees include only part of the structural information of a program. In Java, for instance, class, methods, and fields are nodes in the tree, whereas expressions and statements are hidden in the leaves in the form of plain text. And for these elements not having the structure exploited, semi-structured merge applies the usual resolution of unstructured merge. So previous studies shows that indeed semi-structured and structured merge are able to reduce the number of merge conflicts when compared to traditional unstructured merge for most projects and merge situations. So for instance, in merge situations in which semi-structured merge was able to reduce the number of reported conflicts, Appel found an average reduction of 34%. In a replication of that study with a different sample, we found an even larger average reduction of 62%. However, this reduction is mainly because of automatic resolution of unstructured merge false positives, which are reported when, for instance, developers add independent and different method declarations to the same text area. This evidence, however, is not enough to justify the replacement of traditional unstructured merge by semi-structured or structured merge. The problem is that previous studies do not investigate whether the observed reduction on the number of reported conflicts actually leads to integration effort reduction without having a negative impact on the correctness of the merge problem, of the merge process. The problem is that these strategies has false positives and false negatives. False positives represent unnecessary integration effort, which decreases productivity because developers have to resolve conflicts that are not actual problems, and false negatives leads to build or behavioral errors, having a negative impact on correctness and software quality. Indeed, the reduction on the number of conflicts by semi-structured and structured merge might have been obtained by letting conflicts escape, missing actual conflicts. If that's the case, the detection of the conflict is just postponed to other integration phases such as building and test, or even worse, the conflict escape to the users. So for instance, semi-structured and structured merge assume that the order of import declaration does not matter and allows developers to add import declarations involving members with the same name to the same text area, and this leads to type ambiguity error by the compiler because it cannot determine from which package this list here comes from, okay? Besides that, given that the set of conflicts reported by these strategies are in part different, semi-structured and structured merge could even be introduced in other kind of false positives that are harder to resolve than those they eliminate. So, for instance, renames challenge semi-structured and structured merge because they are not able to map renamed elements. For instance, renamed method declarations. So they assume there was a deletion, and if the developers who keeps the original declaration in red here change its body, declaration body, these strategies reports a merge conflict. So to drive a change in the state of practice, which is unstructured merge today, I mean going from right to left in this figure, we need solid evidence and further knowledge about the difference, strengths, and weakness of these three merge strategies. And is that that's exactly the outline of my work. We compare these three merge strategies to decide whether should we place some merge tools. We compare these three merge strategies to better understand the difference, strengths, and weaknesses. We first compare semi-structured and structured merge. We go further than previous studies and we compare these two strategies in terms of false positives and false negatives. This was published in 2017 in Uppsala. And you answer two research questions. First, when compared to unstructured merge, does semi-structured merge reduce unnecessary integration effort by reporting fewer false positives? And when compared to unstructured merge, does semi-structured merge compromise integration correctness by having more false negatives? The challenge associated with using false positives and false negatives as comparison criteria between these two strategies and the other two is establish ground truth for integration conflicts and therefore false positives and false negatives. In this context, this is not computable. Semantic approximations such as static analysis are impressive and often too expensive in the case of information flow analysis. We could use experts who understand the integrated code, possibly the developers, to determine truth, but not without the risk of misjudgment. So as these options would imply into a reduced sample with limited precision guarantees, we decide to compare these two strategies in relation to the occurrence of false positives and false negatives of one strategy in addition to the ones of the other. We can do that by simply analyzing when the two strategies report different conflicts, different results for the same situation. So we then we identify conflicts correctly reported by one strategy but missed by the other, the false negatives, and conflicts incorrectly reported by one strategy but correctly resolved by the other, the false positives. So to answer our research questions, we adopt a setup based on 3 steps. In the mine step, we use tools that mine GitHub repositories to collect a number of merge scenarios. And in the execution step, each merge scenario consists of the different versions of the merged files, okay? In the execution step, we use tools of buff strategies to merge the selected scenarios and to find potential false positives and potential false negatives. And in the analysis step, we parse and compile the files having the potential false positives and false negatives merged by these tools to confirm them. And finally, we use our scripts to sum up the results. As a result of this mining step, we obtained and we performed this experiment on over the 34,000 merge scenarios from 50 selected Java projects. And given that part of the execution in the analysis step is language dependent, we process only the Java file in these scenarios. And because of limitations, implementation limitations, our metrics are actually approximations. So we compute the overestimated number of semi-structured merge additional false positives and additional false negatives, and the underestimated number of additional false positives and false negatives of unstructured merge. This is not a problem if we found that an overestimated number is lower than an underestimated number, because this means that the difference applies also to the actual values underlying these metrics. Now the results, considering aggregate scenarios of all projects in our sample, we found that semi-structured merge was able to reduce the number of reported conflicts by 24%. To answer with our first research questions, we need to compare the number of additional false positives of each strategy, and we found that the average number of semi-structured merge additional false positives is lower than unstructured merge, and we also found that semi-structured merge has on average, fewer merge scenarios with additional false positives than unstructured merge. So these numbers suggest that semi-structured merge reduces integration effort, but a more accurate comparison would take into consideration the effort necessary to analyze and discard these false positives, because different conflicts might demand different effort. So to better understand the impact on integration effort, we inspected a sample of merged code of the 2 strategies, 50 scenarios for semi-structured merge and 50 for unstructured merge, to better understand the impact on integration effort. When necessary, in a few situations, we also analyzed the history of the project to see how the contributions were integrated. The hypothesis that integrations having code only for the contributions without new code or permutation of the developer's code demands less effort. And the analysis indicate that semi-structured merge additional false positives are easier to resolve than structured merge. This kind of conflict shows the name of the original element with the original body, and in yellow in the picture, and the name of the original element with the new body. So to resolve this kind of conflict, the integrator, based on this information, has to find the element with the new name, the corresponding element with the new name. In resolution is easy. It consists of declaring a single element with new name and new body. We also observed semi-structured merge false positives in which part of the changes are just code spacing, code indentation, as you can see here. The yellow and the red parts are the same apart from the indentation. And it's obvious, at least for Java, has no semantic or building meaning. And resolution is easy too. You just have to choose one kind of indentation and is that. In turn, we found that only part of unstructured merge additional false positives are easy to analyze and resolve. We found that about half of unstructured merge false positives are hard to analyze and resolve, and we call this conflict as cross-cutting conflict. This kind of conflict mixes different parts of different elements, for instance, parts of different methods declaration. To resolve this kind of conflict, the integrator has to map the different pieces of code to the declarations to which they belong. For instance, to each method declaration, the last 4 statement in blue here belongs, and the 3 if statement here belong. Curiously, we found that in about 90% of these conflicts, the resolution was simple. This suggests that although analyze this kind of conflicts hard, resolving them is not, or it might be also the case that analyzing so hard that the resolution of this kind of conflict just consists of discarding part of the contributions. So for our first research question, semi-structured merge came out as the winner. For most projects and merge scenarios in our sample, it reduced the number of reported conflicts, it had fewer false positives, and they are easier to analyze and resolve than those from unstructured merge. Now for our second research questions about false negatives, we have to compare the number of additional false negatives of each strategy, and this time we found the contrary. We found that the average number of semi-structured merge additional false positives is greater than unstructured merge, and semi-structured merge also had on average more scenarios with false negatives than unstructured merge. When comparing false negatives, the greater is the number of false negatives, the greater is the number of post-merge build and behavioral errors. So the weaker is the correcting guarantees of the merging process. So these numbers suggest that unstructured merge beats semi-structured merge. And note also that some bugs are more critical than others, and compilation problems can be automatically detected, whereas behavioral errors are harder to detect. And in that sense, unstructured merge also beats semi-structured merge because its additional false negatives leads to compilation problems, guiding the developers towards the cause and location of the problem. So to be more precise, unstructured merge does not report conflict when developers add declarations with the same identifier to different text area, and this leads to duplicated declaration by the compiler, so the developer can easily find the location, the cause of the problem. In this case, semi-structured merge is able to match the duplicated elements because of the same type and the same identifier. However, structured merge additional false negatives might involve subtle errors. When developers, for instance, oh, there is a mistake here, okay. When developers add different but dependent elements to the same text area, unstructured merge reports a conflict, but semi-structured merge does not because they are different nodes, they have different identifiers, and there is no compilation error, but there might be a behavioral error, which is even worse. So in this example, the added method in red, set status method by the first developer, might not be expecting the extra notification in blue added by the second developer to the method Bluetooth notify change. So the expected behavior of the integrated code might not be the one that both developers expect. So for second research questions, we found no evidence that semi-structured merge has fewer false negatives than unstructured merge, and they are harder to detect and to resolve. Okay, just a minute. So our evidence of conflict reduction and false positive reduction will hardly be sufficient to justify the replacement of unstructured merge by semi-structured merge, because of the risk of loss in part of the merge scenarios, and also because of the extra risk and complexity associated with its additional false negatives. Even so, our results allowed us to develop an improved semi-structured merge tool that further combines semi-structured and unstructured merge to reduce the additional false positives and false negatives of semi-structured merge. So basically, the tool implements the algorithms underlying the scripts we used in the experiment to detect false positives and false negatives. So there is a handler for semi-structured in the form of conflict handlers. So there is a handler for semi-structured merge additional false positives and 3 kinds of semi-structured merge additional false negatives. After the merge tree is constructed, each handler updates the merge tree based on specific analysis from information collected during tree construction. And a major concern for the design of our tool is ensuring that whenever possible it's not worse than an unstructured merge tool to justify the adoption of our tool. So we call unstructured merge whenever the underlying algorithms are not accurate. The tool is also can also be applied to any kind of textual content, including non-Java files. In this case, we invoke unstructured merge. And the tool is also able to resolve conflicts due to code indentation. After installed, the tool is completely integrated with Git version control systems. So whenever the user calls the git merge command, our tool is invoked, and it generates the results in the same format of default git merge. And of course, the tool can also be used standalone. As an example of handler, let me show the type ambiguity error handler. This handler uses compilation features to detect compilation problems related to import declarations. So we store and we identify and store pairs of nodes representing edited or added import declarations. And afterward, the handlers compile the semi-structured merge output having the pair of import declarations and search for compilation problems related to type ambiguity error. In case the handler find a type ambiguity error, the handler notifies a conflict. So the improved tool completely eliminates semi-structured merge additional false positives because it uses unstructured merge as oracle. So it won't report a renaming conflict if unstructured merge reports an equivalent. And the tool is also able to eliminate a few kinds of false negatives. So this time the improved tool actually beats unstructured merge in terms of false negatives with respect to the overall merge scenarios in our sample. And you also need to demonstrate that our tool is non-prohibitive in terms of performance. And we found that although it's lower than unstructured merge, which is actually expected because the syntactic nature of semi-structured merge and also the extra complexity of the handlers. So although the improved tool is lower than unstructured merge, on average, it took less than 1 second per merge scenario. Actually, less than 1 second in 8% of the merge scenarios and more than 5 seconds in only 2% of the merge scenarios. Okay, this finishes the first part. Let's do the second one. So we found that semi-structured merge has advantages over unstructured merge, especially as implemented by our improved tool. Besides that, there is evidence that structured merge reports significantly less conflicts than unstructured merge. However, it was unknown how semi-structured merge compares with structured merge. So before deciding to replace unstructured merge by semi-structured merge, we need to investigate whether structure merge isn't a better option than semi-structure merge. So this piece of work was accepted to appear at Automated Software Engineer on next month. And okay, merging problems for these two strategies consists of traversing trees to find different nodes. In this process of tree traversal and comparison, nodes are matched based on the type and name. So for instance, two method declarations are matched if they have the same signature. So the main difference between semi-structure and structure merge is the exploited syntactic granularity. A key point for structure merge, as implemented by the 2J DIME we use when comparing trees, is the distinction between ordered nodes, which must not be permuted. So the position of the child nodes in relation to the parent node is relevant, and unordered nodes which can be permuted safely, so the position of the nodes does not matter. For ordered nodes, they will be in conflict if the position of the chains overlap, and for unordered nodes, they will be in conflict. It will depend on the type and the name of the node. You might have already noticed, but there are a lot of similarities between semi-structured and the structure merge. Actually, semi-structure merge is equivalent to the merge of unordered nodes by structure merge. So that similarity with respect to unordered nodes means that these two strategies have in common limitations and solutions. So structure merge have in common with semi-structure merge its additional false positives and its additional false negatives demonstrated in the first study. And as expected, structure merge is also able to deal with unstructured merge additional false positives and additional false negatives. So to better understand the differences, strengths and weaknesses of these two strategies, we have to focus on where these two strategies behave differently. And this happens inside declaration bodies at the level of expressions and statements, the ordered nodes, for which semi-structure merge applies unstructured merge and structure merge applies the syntactic merge. Let me show an example. In this example, the base version shows a method that adds a new key value to a map. The first developer in red refactored the code by extracting the key variable, and the second developer added an extra argument to the constructor call in blue. As developers change different nodes from the base version, structure merge does not report a conflict. However, semi-structure merge reports conflicts because it detects that both developers change the same line in declaration body. Actually, they change consecutive lines. No, they only change the same line, key and the argument. So this is an example of semi-structure merge false positive correctly resolved by structure merge, and this is a false positive because part of the changes in red are just refactoring. Even if the first developer had simply added a single comment before the method call, semi-structure merge would still report a conflict because the invoked unstructured merge report a conflict whenever it cannot find a line that separates developers' changes. And as before, structured merge is able to resolve that conflict. We call these consecutive lines conflicts. So the previous examples are semi-structured merge false positives, so the users perhaps would prefer to adopt structured merge instead. However, there are slightly different examples in which the first developer, besides extracting the key variable, also changed its value to j. So the tools would behave exactly as before, but this time the behavior expected by the first developer, new key with old value, and the second developer, old key with new value, will not be observed when running the integrated code. So this is an example of structure merge false negative, correctly detected by semi-structure merge by accident, of course. So in this case, the preference would be for semi-structure merge, the tool that reports a conflict when integrate these changes. So to better understand the difference, the strengths and weaknesses of semi-structure and structure merge, we answer a number of research questions. Question number 1 is how many conflicts arise when using semi-structured and structure merge? So to answer these research questions, we merge the chains of each scenario with both strategies, and for the result of each strategy, we count the total number of reported conflicts by each one. Question number 2 is how often do semi-structured and structure merge differ with respect to the occurrence of conflicts? To answer this research question, we assess how many merge scenarios have conflicts reported by only one of the strategies. Okay, so these two strategies could still differ when they both report conflicts for the same merge scenario, because the conflicts might be different. But we observe that when semi-structured and the structure merge reports conflicts for the same scenario, these conflicts might be different, but they are equivalent. I mean, the textual representation of the conflicts is different, but the meaning is the same. I will show an example of that later. Question number 3 is why do semi-structure merge and the structure merge differ? So we answer these research questions to better understand the difference on the behavior of the two strategies that leads to diverging results. So we inspect the code, the changes in the merged code by each strategy for a sample of merged scenarios having conflicts reported by only one of the strategies. Question number 4 is which of these two strategies reports fewer false positives? So to answer this research question, we rely on build and test information of the changes in the integrated code, and we also inspect the changes in the integrated code. Question number 5 is which of the two strategies has fewer false negatives? Again, we rely on build and test information about the integrated code to answer this research question. And finally, our question number 6, does ignoring conflicts caused by changes to consecutive lines make the two strategies more similar? The hypothesis here is that if semi-structure merge was able to resolve consecutive lines conflict, its behavior, its output would be more similar to structure merge. So to answer this research question, we check whether semi-structure merge conflict is because of changes in consecutive lines, and we contrast the results of previous research questions with and without consecutive lines. So by just reproducing merge scenarios with the two strategies plus a manual inspection of the merged code to understand why the strategies differ, we are able to answer most of our research questions. However, answering the questions about false positives and false negatives is more challenging. So we first attempt to build the merge scenarios free of conflicts that not result in conflicts with only strategies, but that resulted in conflict with the other strategy. So this is a scenario for which the two strategies differ. If the build succeeds, the build is okay, and all tests pass, we still need to inspect the change in the merged code to confirm, to make sure that there is no interference between the developer changes. Passing all tests is a good approximation, but there is no guarantee that there is no interference between developers' changes. So this is we need to inspect the merged code and the changes. In case we found no interference, then we count a scenario with false positive for the strategy that report merge conflicts. On the other hand, if a build breaks or at least one test fails, or we find interference when analyzing the changes, we count a scenario with a false negative for the strategy that did not report conflict. We use Travis continuous integration as infrastructure for building and executing the tests of the code. And there are scenarios with issues unrelated to the merged contributions. For instance, unavailable dependencies, timeout, and much more. So we also inspect a sample of these undetermined builds to find false positives and false negatives. Note that in the first study, the differences between unstructured and semi-structured merge allowed us to create a list of false positives and false negatives and compare the two strategies based on that list. However, when comparing semi-structured and structured merge, the differences at the level of expression and statements are much more subtle. So, because of that, we have to adopt this setup but based on building and testing. To ensure that we have structure merge working as specified, we actually use a single tool that is able to select semi-structured or structure merge to merge declarations body. So, I mean, that distinction between ordered nodes for which the two strategies differ and unordered nodes for which the two strategies are equivalent, we need that single tool. So when semi-structured merge is selected, unstructured merge is invoked to merge declarations body, and when structured merge is selected, the tool actually calls JDIME. Our sample for that second study is based on two data sets of projects that adopts continuous integration. So for these two data sets, we filter Java projects that uses Travis and Maven as build manager. There are scenarios, we filter out scenarios in which the base version or the variants have already issues on Travis, otherwise we are not able to affirm that the issues on the merged code are because of the contribution. It could have been inherited from the parents if you do not filter these scenarios. And now the results, by reproducing thousands merge scenarios for hundreds of projects, we found that the number of reported conflicts by the two strategies is very close, with a slight advantage for semi-structured merge. This at first might surprise who expects that more structure leads to conflict reduction. But when we inspected the merged code, we found that structured merge conflicts are more granular. This allows the same conflicting situation to have different representations by the two strategies. So in this example, both developers add the same constructor, and for this case, structure merge reports a conflict for any two difference between the versions, resulting in several small conflicts because there is no base version of the constructor. And semi-structure merge reports a single conflict for the entire constructor declaration. So in this example, you can notice that the textual representation is different, but the meaning of the conflict is the same. So to control for the bias of conflict granularity, we also consider the number of merge scenarios having conflict. And in this case, we found that the number of conflicting merge scenarios is reduced by about 90% when use structure merge instead. For question number 2, we found that the number of scenarios in which the two strategies differ is almost negligible in relation to the total number of merge scenarios in our sample. This happens because most of scenarios are free of conflicts, regardless the adopted strategy. These scenarios change only different files, so there is no difference between the adopted strategies because there is no chance of conflict at all. But When we consider the number of scenarios in which the two strategies differ in relation to the conflicting scenarios, which reflect more complicated merge situations, the kind of adopted merge strategy makes a difference. So this time we found that the number of merge scenarios in which the two strategies differ is about 24%. But if we consider that most changes and code are inside the declarations body, exploited by the significant extra structure of structure merge, this number might be considered low. Okay. So for question number 3, by analyzing developer changes, the conflict reported by one strategies and the code integrated by the other strategy, for a sample of merge scenarios, a random sample of merge scenarios, we found that semi-structure merge reports a conflict and the structure merge does not report when changes occur in overlapping test areas that corresponds to different tree nodes. Let me show an example. In this example, the first developer in red created the instance object and passed it into the init method call. And the second developer added the configure method call. So as these changes are in different nodes in the representation of structure merge, it does not report a conflict, but semi-structure merge report a conflict because it detects the change are in overlapping test areas. In this example, actually the changes are in consecutive lines, so it reports a merge conflict. Now, structure merge reports a conflict and semi-structure merge does not report when changes occur in non-overlapping test areas that corresponds to different but incorrectly matched nodes and to the same node. Let me show another example. So in this example, the first developer in red added a call to view model to an existing method called chain, and the second developer changed the argument of the call to provided in the same chain. When integrating these chains with semi-structure merge, it detects the chains are in non-overlapping test areas with the line that calls context acting as a separator between the areas, so they do not overlap and it do not report a conflict. But structure merge incorrectly concludes that both developers changed the left child of the second method call node. Note that the three nodes at that position are different because of the added call to view model. So as the nodes at the same position are different, structure merge reports a conflict. Now for question number 4, which is based on the number of merge scenarios with a successful build and for all tests passed, together with a manual inspection of the changes in integrated code, we found that semi-structure merge had 11 times more scenarios with false positives than structure merge. So for these scenarios, the build was okay, all tests passed, and we did not find interference when inspecting the change, so the conflicts are unnecessary. The conflicts are false positives. For question number 5, about false negative, the situation is reversed. This time we found that structure merge had about 6 times more merge scenarios with false negatives than semi-structure merge. So for these scenarios, the build was broken, at least one test failed, or we did find interference when inspecting the change. So the two that not report the conflict actually missed the conflict. Okay. Finally, for our last research question about consecutive lines conflicts, we found that when semi-structure merge is able to resolve conflicts because of change in consecutive lines of code, the number of scenarios with conflicts by semi-structured merge is reduced by about 3%, and the number of scenarios in which semi-structured and structured merge differ is reduced by about 11%. Why this happened? We observed that changes in consecutive lines of code usually correspond to different tree nodes in the representation of structured merge. So for this situation, structured merge does not report conflict. So when semi-structured merge is able to resolve conflicts because of change in consecutive lines, it might avoid conflicts because of change to different nodes similar to structured merge. Note that we only counted the number of consecutive lines conflict. We actually do not resolve them, and this is why we don't have numbers for false positives and false negatives. So here we are back at the main question of this work. Should we replace our merge tools? Yes or no, Leopoldo? Literature suggests that more syntactic structure leads to more tools accuracy, but that was not what we observed. Okay. On side there is unstructured merge. It's fast. It works with every kind of textual content, including source code, but it might report too many false positives. In the other side, there is structured merge. It's very expressive. It reports significantly less conflicts than unstructured merge, but it has a tendency to false negatives. It has a performance overhead, and this kind of tool is not easy to develop. And in between these two strategies, there is semi-structured merge. It reports fewer false positives than unstructured merge, and it misses fewer false negatives than structured merge. So we believe that semi-structured merge is a better replacement of unstructured tools for conservative developers, developers that are not overly concerned with semi-structured merge additional false positives, and also because semi-structured merge output behavior is more similar to unstructured merge, so the developers will be more comfortable, perhaps, than structured merge. Even so, tools can still be improved to get close to an ideal spot, a sweet spot. I demonstrated the benefits of using conflict handlers to deal with specific kinds of conflicting situations, and I also demonstrated the benefits of resolving consecutive lines conflicts. So this is a line of research. And we can also in the future investigate a combination between semi-structured and structured merge to reach that sweet spot. That combination has the potential to reduce semi-structured merge false positives and reduce structured merge false negatives. So that's our evidence. It's time to you to decide, should we replace our merge tools? Thank you so much.